Hello, welcome to my channel, The X. Have you ever wondered why a helium balloon defies the universal law of gravity and rises upwards? It's a sight we've all seen, yet its mystery is often lost amid the dazzle of birthday parties and parades. A balloon filled not with ordinary air but with a gas that seems to laugh in the face of gravity's pull. It's a curious spectacle, one that begs the question, how exactly does helium work against gravity? It's a fascinating phenomenon, isn't it? Let's unravel the science behind it. To understand how helium works against gravity, it's essential to first understand what gravity is. Now, imagine you're holding an apple and you let go. What happens? It falls, right? That's gravity in action. It's the force that pulls objects towards each other. The bigger the object, the stronger its gravity. That's why everything falls towards the Earth. It's pretty big. Gravity is a fundamental and universal force. It's the glue that holds the universe together. Without it, we'd all be floating aimlessly in space. Planets wouldn't orbit the sun, and galaxies wouldn't form. It's also the reason why we stay grounded, and why when we jump, we come back down. So, how does it work? Well, let's take a trip back to the 17th century, when an English physicist named Sir Isaac Newton discovered the law of universal gravitation. According to Newton, every object in the universe attracts every other object with a force that's directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Sounds complicated, right? Simply put, if you increase the distance between two objects, the gravitational pull decreases. Conversely, if you increase the mass of the objects, the gravitational pull increases. But wait, there's more. Albert Einstein, in his theory of general relativity, explained gravity not just as a force, but as a bending of space and time around massive objects. Picture a bowling ball on a trampoline. The ball creates a dent, and if you roll a marble near it, the marble will roll towards the ball. That's a simplified model of how gravity warps space and time. So, gravity pulls everything towards the Earth's center, but then how does helium seem to defy it? A helium balloon floating in the air is a common sight at parties. But have you ever stopped to ponder why it floats? This seemingly simple question opens the door to a fascinating scientific investigation. The secret lies in the unique properties of helium and its interaction with our planet's gravitational field. At first glance, it might seem like helium is defying the universal law of gravity, the very force that keeps us grounded on Earth. After all, when you let go of a helium-filled balloon, it doesn't fall to the ground like most objects. Instead, it rises, soaring towards the sky as if pulled by an invisible string. This behavior, contrary to our everyday experiences, makes helium balloons an intriguing scientific conundrum. Yet the truth is, helium doesn't possess anti-gravitational qualities. It's not rebelling against the laws of physics or performing some magical feat. On the contrary, helium, like every other element, is obediently following the rules set by nature. The key to understanding this mystery lies in the air around us and the nature of helium itself. The air we breathe is a mixture of various gases, primarily nitrogen and oxygen, which are heavier than helium. When you fill a balloon with helium, you're essentially replacing the heavier air inside with a much lighter gas. This makes the overall weight of the balloon lighter than the air it displaces, causing it to float. But it's not just about weight. The particles of helium gas move faster and collide with more energy than the particles of air, creating an upward force that helps the balloon rise. This is due to helium's low atomic mass, which allows its particles to zip around quickly, even at room temperature. So, when you see a helium balloon bobbing in the air, remember that it's not defying gravity. It's simply lighter than the air around it and is being buoyed upwards by the faster, more energetic helium particles inside. It's a beautiful example of science at work, hidden in plain sight at our parties and celebrations. In reality, helium doesn't defy gravity. It simply follows a different set of rules. Curious to know how? Stay with us. Helium, the second lightest element in the universe, behaves differently than most substances when exposed to gravity. You see, helium is a noble gas, and it's one of the most abundant elements in the cosmos. It's an atomic number 2, meaning it has 2 protons, 2 neutrons, and 2 electrons, making it very stable. It's these properties that make helium an interesting subject when it comes to gravity. Now let's talk about why helium is lighter than air. Our atmosphere consists primarily of 2 gases, nitrogen and oxygen. The average molecular weight of air composed of these 2 gases is around 29 atomic mass units. However, a helium atom weighs just about 4 atomic mass units. This makes helium significantly lighter than the air around us, but it's not just the lightness of helium that makes it rise. The principle of buoyancy also plays a significant role. As helium is lighter than air, it displaces the heavier air molecules around it, causing the balloon to rise. This is similar to how a cork or a piece of wood floats on water. The cork is lighter than the water it displaces, so it floats. Another fascinating aspect about helium is its low boiling point. It remains in a gaseous state at temperatures where most other elements would have long since become a liquid or a solid. This is due to helium's low intermolecular forces, which means it doesn't stick together as easily as other gases. This also contributes to helium's ability to rise, as it remains a gas even when other gases might have condensed. Also, helium is monatomic, meaning it exists as single independent atoms rather than as molecular pairs like most gases. This further reduces its density, making it even lighter than the majority of gases we encounter. So, helium being lighter than air is what makes it rise. But there's more to it than just that. We'll delve into the Archimedes principle in our next scene to understand even more about helium's fascinating defiance of gravity. Ever heard of the Archimedes principle? It's the key to understanding how helium works against gravity. Archimedes, a famous Greek mathematician and inventor, came up with a principle that changed how we understand the behavior of objects in fluids. This principle states, an object submerged in a fluid experiences an upward force equal to the weight of the fluid displaced by the object. Sounds complicated? Let's break it down. Picture a bathtub filled with water. Now imagine dropping a rubber duck into it. The duck displaces a certain amount of water, creating a space that the water used to occupy. The water pushes back, trying to fill this space, and that push is what we call buoyant force. This force is exactly equal to the weight of the water displaced by the duck. If the duck is lighter than the water it displaces, it floats. So, how does this apply to helium balloons? Well, air, just like water in our bathtub example, is a fluid. When you fill a balloon with helium, it displaces an amount of air. Just as with the rubber duck, the air pushes back with a force equal to the weight of the air displaced by the balloon. Helium is much lighter than air. So when you fill a balloon with it, the balloon itself becomes lighter than the amount of air it displaces. As a result, the buoyant force acting on the balloon is greater than the weight of the balloon, causing it to rise in the air. The balloon will continue to rise until it reaches a point in the atmosphere where the weight of the displaced air is equal to the weight of the balloon. At this point, the buoyant force and the balloon's weight are balanced, and the balloon stops rising. So, it's the Archimedes principle that explains why a helium balloon rises in the air. This principle not only helps us understand the science behind floating balloons, but also opens the door to a world of fascinating concepts in fluid dynamics and beyond. Let's summarize what we've learned about helium and gravity. We've taken a fascinating journey, starting from the unexpected question, how does helium work against gravity? We started by understanding the basics of gravity itself, a force that pulls everything towards the center of the Earth. It's what keeps us grounded, literally. Then, we moved on to the mystery of the helium balloon. Unlike most things, a helium balloon rises, seemingly defying gravity. This left us with the question, how does that happen? To answer that, we delved into the science of helium. As it turns out, helium is a light gas, lighter than the air around it. This difference in density is what makes a helium balloon rise. It's not actually working against gravity, but rather using the principles of buoyancy. This brought us to the Archimedes principle, a fundamental law of physics. It states that any object, wholly or partially immersed in a fluid, is buoyed up by a force equal to the weight of the fluid displaced by the object. In the case of a helium balloon, the helium inside is lighter than the air it displaces, making the balloon buoyant and causing it to rise. So next time you see a helium balloon floating in the air, you'll know exactly why it's there, defying gravity in its unique way. Thanks for watching. Stay tuned for more interesting videos like this. Like, subscribe, and share. Have a nice day.